Now let's talk about passing arrays to functions. Now arrays in a sense are passed to functions similarly to how we pass other arguments, other variables, by specifying the array's name, but without any of the square brackets. For example, if we have an array called hourly temperatures and of size hours in a day, so that is some symbolic constant, of course. So we have this integer array, and we want to pass it to a function called modify array. We would do it like this, like this, like in a statement like this. It's a call to a function modify array, and over here the first argument it's taking is the name of the array. Notice that the square brackets are absent. And the second argument this function takes is hours in a day over here. That is basically the size of the array. It's a good idea to pass the size of the array alongside with the name of the reference to the array, because remember, when you pass an array, the receiving function cannot find out on its own how large the array is, how many elements are in it, what its size is. You cannot use the size of function for that. Doesn't work like that. Doesn't work with arrays. So you have to specify, you have to send that information as a second argument, like it's done over here. Now, when you pass an array in C, it is automatically passed by reference. And what do I mean by that? The name of the array, just the name of the array as it is being passed as an argument over here, is basically the address of the first element of that array. That means what's actually going through to the called function is not a copy of the entire array, like has been happening for other parameters we have passed to functions up to this point. Instead, if you imagine, once again, this being the memory of your system, and let's say the array we are dealing with takes up these memory locations, starting from here, ending over here. And in this example over here, we have 1, 2, 3, 4, 5, 6 elements in this array. Then when you use the name of the array, what you're basically referring to is the address 0, 0, A, B, 3, F in hexadecimal number format. You're basically sending the location, the address, the place in memory where your array is located. When you pass a variable like this is called passing by reference. Now, we talked about that a little earlier. So basically, the main function in this case, which contains some array, let's call it A, of a certain size, let's say 6. If it calls a function, let's call it f1, and passes it array A, and let's say also its size, instead of creating a copy of this entire array over here in another place in memory somewhere and giving that to function f1, what's happening instead is this memory location is being sent to f1, which means if function f1 makes any changes to any of the elements in the array it has received over here, those changes will also be visible, will also affect what's happening in the main function when function f1 returns to main. So when an argument is passed, and in this case an array argument is passed by reference, and the called function modifies the elements of that array, it is modifying the elements of the original array. This can be very convenient if what you're trying to do is communicate between two functions. You can use it for that. But this can also become the cause of trouble depending on what you're trying to do, what your code should be doing. Remember, when a function returns, what we have seen so far, it can return one integer or one floating point number or one of something, one of some data type. But what if you want to return more than just one value? We haven't seen that happen so far. Now, one possible way of doing that is to let the called function make changes to elements in an array and to an array that has been passed to it by reference, and that can be another mechanism for a called function to basically send back values to the calling function. Think about that. Now, in the example that we just saw, we passed the array by just giving its name. So let's say an array is called array. We would, in that case, the argument passed through the function is array. That's it. However, this is, and I would, as I explained, that is the address, the starting address of the 0th element of that array. Now, based on what we already know, the 0th element of the array is this one. This is how we would refer to that. And if we want to refer to its address, we already know from frequent use in scanf functions that the address of a variable can be referred to by adding an ampersand sign in front of that. So this means the same thing as this. The name of the array is basically a reference to the first element, the address of the first element of that array. Or you can also say the same thing or mean the same thing. You can also refer to the starting address of the array like this. You can skip the square brackets. All three of these mean the same thing. You can use any of these without causing an error. Of course, the first one is the simplest, and that is what we typically use. We'll see that in a small example in which we print out all three of these for an array and print them out as pointers, as addresses. This is something I've already shown you a little earlier, a couple of weeks earlier in one of the hands-on sections. So %p is the conversion of format specifier that converts a number into an address. Usually, depending on what system you are, that can be different, but on a Windows machine, on a Linux machine, on most machines, that will be in the form of a hexadecimal number. But like I said, that is compiler dependent. Hexadecimal numbers are, of course, numbers with base 16. And the 16 digits are the digits 0 through 9 that we already use in the decimal system. And the 11th to 16th digits are the letters, usually in capital, A, B, C, D, E, and F. So those 6 letters are treated as digits, but you should already know that, I guess. There are other numbering system, of course. Addresses can also be represented in binary form. Representing them in hexadecimal form just makes it more compact, or in octal form, less frequently used. Decimal form used very infrequently for this purpose. An example of memory location in hexadecimal format is something like this: a mix of numeric digits and the first 6 letters of the English alphabet. Now, passing arrays by reference makes good sense for performance reasons, because when you pass arguments by value, you have to create copies in memory of those past variables, of those past arguments. When you pass an array by reference, that becomes unnecessary. Instead, you just pass on the address of the existing array. So it also makes for faster code. Here's an example that demonstrates how all three, referring to an array just by its name, using the ampersand and the square brackets with for the 0th element, or using just the ampersand sign with the array name, how those actually all give you the same address. They all mean the same thing. They all refer to the same address of an array in memory. And what we're doing over here, we have a main method. We create a small array 5. We don't even bother to initialize it. And we print out array, ampersand array 0, and ampersand array formatted as pointer addresses. We print those out, and this is the output that you get. The addresses, or when you run this, of course, these addresses can be different every time. Now, it is possible to pass an array by value if you really need to. But for that, we need to use something called a structure, something that uses the struct keyword, which we haven't used yet. We'll get to that in chapter 10. Now, although when you pass an entire array, it is passed by reference, you could pick out one element of an array, one, not two, just one, and pass that by value. You can, of course, do that by simply referring to that element. So if we have, array, and you want to array, and you want to send this element number 2, you can send it like this in an argument list of a function, and this will be passed not by reference but by value, just like any other regular integer or double argument or a character argument that you would send. Now that we're talking about arrays, I would like to introduce another term for the basic data types that we have been using in C. Those are also sometimes also called native data types. And another name for them, for the integers, floating point numbers, double floating point, precision floating point numbers, characters, another name for them is scalar. So we will demonstrate how to pass an element of an array as a scalar in the next example. Now, what about the function that to which we pass an array as a reference? Well, in the definition of the function, you have to specify that an argument happens to be an array, and you do that by adding these empty square brackets after the name of the array. If you wouldn't do that, that would just mean this function takes an integer b, a scalar. But because we are passing an array over here, you have to add these square brackets. And the same thing in the function definition, of course. It is not necessary to include the size of the array over here. That is meaningless. All the compiler will do is check that even if you want to include a number, that's fine. All the compiler will do is check if that value is greater than 0. If it is, it ignores it. If the number that you put in is a negative number, you will get a compiler error. So just like in other functions, the called function may use a different name to refer to the array. That's perfectly fine. Now let's take a look at the difference between passing an entire array by reference and passing one element of an array by value. And what we're going to do for that is quite straightforward. We're going to have a function. First, we're going to have a main function in which we have a 5-element integer array called a. And we're going to pass that by reference to a function called modify array. And that function will multiply each element of that array by 2. And then when we come back to the main function, we print the values of all elements of a, and you'll see they will have doubled since before the function call, since before calling modify array. And that will show that when we pass an array by reference, changes made by the called function are seen, are reflected back in the calling function, in the main function in this case. So main will pass array a by reference to function modify array. It will multiply every element by 2, which will be seen back in the main function. And after doing that, what we'll do is we'll also create another function called modify element. And this function will be given as argument only element a3. And modify element will multiply the argument it receives by 2 and print out the new value. But when we return to the main function and reprint the value of a3, we will see that it will remain unchanged because a3, the single element of the array, will have been passed by value, just like all the other parameters of native data types that we have been passing to functions up to this point. Now, there may be some situations in which you want to really prevent a function from making changes to elements of an array. And you can actually enforce that, you can control for that by using the keyword const, which is short for constant. In the called function, you can declare you can declare the array that you're receiving by reference. You can declare it constant. I'll show you that. And that will, if inside the function at any place you try to modify an element of that array, that'll give you a compile time error. And here's the code we have for this example. We have the modify array function, which is taking 2 arguments. One will be an integer array that will be referred to as array b inside modify array function, and the other one will be its size, which is of size specified as type size underscore t. And then we have the modify element function. There's nothing new to that. It receives an integer by value and will also multiply it by 2. And here's the main function. We create array A of size 5, initialize the values to 1, 2, 3, 4, 0, 1, 2, 3, 4, print out a nice string, and print out the original values, the starting values of all elements of array A. Print those out using a loop going from 0 to 4. And then we call modify array, which passes the array A by reference. When we return, we print out the values of A again, and we expect to see all elements in array A be doubled by then. So expect to see 0, 2, 4, 6, 8 in that. Okay, then we print out the value of A3 and call modify element function and pass it element A3 of this array A. And when we get back, when we return from that function, we print out the value of A3 again. And since we're passing a single element over here, this element will be passed by value. Any changes made to it will remain inside the modify element function, which means when we print out A3 out here in the main method function again, it will be the same as before. And here are the two functions. Modify array receives an integer array that it refers to as B. It has a for loop that multiplies all elements of B by 2, and it goes from 0 to whatever size has been received as argument, as the second argument over here. And the modify element function just multiplies E by 2 and prints it out. If you run this program, this is what we expect to see. Helpful message. The value stored in array A before calling the modify array function 0, 1, 2, 3, 4, the values we initialized it to. Then we call modify array function. After we come out, we print out the values of A again, and you can see they've all been multiplied by 2. Well, we can't tell about the first element, of course, because it's 0, but the effect is clear. So changes made to an array that has been passed by reference are seen back in the calling function, the main function over here. Then with A3 equal to 6, we proceed. We print out the value of A3, which is 6. We call the modify element function, which doubles it. 6 becomes 12. So the value of E goes from 6 to 12. We return from modify element and print out A3 in the main function again. And you can see that the value is still 6 because A3 was passed by value. Changes made to the received element inside the modify element function are not seen after we return from that function. Now, I mentioned that we have this const, short for constant keyword, to protect a function from being modified, from an array from being modified by a called function. And for that, to demonstrate that, we will add then another function, try to modify array. We're going to call it that. We're going to send it as an argument, the integer array referred to as B by the called function, and we're going to add the const keyword in front of that. And we will then try to change the values of some values of that array, and we'll see what happens then. And this is the function that we'll add to that. I'll call that in the main function as well, and you'll see that this will produce errors because the passed array has been declared constant.